This video is a walkthrough of our virtual simulation, which is filtration. Now, once you click the link posted on our LMS, we are going to be led with this dashboard. Okay. Now, the first one we're going to do is to enter our name. Why? Because you will receive a completion certificate at the end of the module. Enter the name you would like to appear on that certificate. Now, since this is a video lecture, I'm going to use something that is out of the norm. Sensei Joe. Now let's click continue. Now, after clicking the continue button, we're going to be led with these two toolbars. The first section is all about overview. We're going to discuss the components of a filtration process. And the second one is all about simulator. I'm going to discuss separately, okay, or on a separate video all about the simulator for our filtration experiment. Now let's click overview. Okay, let's define filtration. Filtration is the process of passing a solution through one or more permeable membranes so that these solutes in this solution are filtered out. Take note of this. Okay, this is a material separation process wherein a solution is passed through a filter media so that we can separate the solutes and the solvents. Okay. Now, the product that is left behind or the product that is on top of a filter media is called as retentate. Okay. And the product or solvent that passes through the membrane is called as permeate. Okay. Now let's click continue. Filtration can happen either using the first one is the gravity. This is the simplest filtration method and sometimes or oftentimes the cheapest one. Okay. Now, gravity filtration is employed on our coffee makers. Now, the second one is by increasing the pressure. Okay. When we employ pressure to the process, we can speed up the time it takes to filter a product, but it can also lead to clogs and the filter or finer particles passing through the filter membrane that would have otherwise been caught. Okay? Now, this is the downside of pressure or employing pressure on the filtration process. There is formation of clogs and sometimes the retentate passes through other filter membrane. Now, we have different types of filtration. The first one is the dead end filtration. The solution flow is passed directly into and through a filter. Okay? As you can see here, the solution is passed directly or perpendicularly with the filter, and as the solution passes and separates the retentate, okay, this part of the solution as it's passed the filter is called as permeate. Now, the second one is the cross-flow filtration. This is the process by which majority of the solution flow is passed tangentially. Okay? If we're going to pass this solution, this is parallel to the filter or tangentially to the filter's surface rather than directly into the filter. This method has the advantage of longer filter life with less risk of filter becoming clogged, unlike the dead end filtering. Now we have different types of filters. Okay, let's continue. The first one is reverse osmosis. Reverse osmosis filtration occurs when pressure is applied to highly concentrated solutes solution to push the solution through a membrane to a lower concentrated solution on the other side. Now, in the process, the high concentrated solute is filtered out by the membrane and only the solvent passes through. Now, RO stands for reverse osmosis. Now we have RO filters can range in pore size from zero point 0.1 to 5,000 nanometers. Now, this is the smallest pore size for a filter. Okay. The second one is nano. The nano filter is a membrane-based filter with pores ranging from 1 to 10 nanometers in size that pass at 90 degrees through the membrane. Nanofilter pores are smaller than ultrafilters and microfilters, but larger than reverse osmosis filters. Okay? And then we have ultrafiltration. It is a membrane filtration method that contains pores that are generally 1/10 the size of the particle to be separated in this process. Pressure or concentration gradients are used to separate solutions through semi-permeable membrane. And we have the microfiltration, uses a process that can accommodate particles. Okay? We have the size range as zero point 0.1 to 10 micro or micron or micrometer, using low to moderate pressure, high velocity to separate solutions through semi-permeable membrane. Now, microfilters are often used as a pre-treatment method for other filtration processes such as ultrafiltration. Now, this is the first stage actually of filtration processes. We have micro followed by ultra, nano, and lastly, we have reverse osmosis. Now, we have the pore size for reverse osmosis as the smallest compared to the other three. We have micro as the largest pore size, followed by ultra. Okay. Now, the size of the pores of ultra filtration is smaller than micro, but nanofilters have pore sizes that are smaller than ultra and micro. And lastly, we have reverse osmosis has the smallest filter pore sizes compared to the other three. Now, now we have a challenge here. This completes the filtration overview. You may review the information again by selecting Let's Review option, or you can select I'm ready. Now, in this instance, I'm going to click I'm ready. It's in your courtesy to click Let's Review. Now, what is filtration? Okay. We're going to choose the best response. Filtration is the process of passing a solution through one or more permeable membranes so that the solution are filtered out. Now let's click letter A. Continue. What is cross-flow filtration? Now remember this is parallel to the filter where solution is passed through a filter parallel or tangentially. A process where majority of solution flow passes through the filters? No. A process where the majority of the solution flow is circulated around the filters? Okay, let's click letter C. A process where the majority of solution flow is passed tangentially or parallel across the filters. Continue. What is reverse osmosis filtration? Using pressure to filter a lower concentrated solution? No, this is more on for highly concentrated solution. Now, the solution that passes through membrane is called as permeates. And then what benefit does adding pressure to a filtration process have over traditional gravity-fed filtration process? Now, this is to shorten the time it requires to filter a solution. Reduce clogs filtration, no. Better filtration, no. This is for letter A, speed. Continue. Okay. Now, congratulations, you have successfully completed section 1 filtration overview. Our next video is all about the simulator or second section or section 2 of our virtual experiment.